How to prevent tear out and burn marks in CNC woodworking. If you've ever used a CNC router, chances are you've experienced this moment. You finish a cut, look at the edge of the plywood or hardwood, and instead of a smooth professional finish, you see chipped fibers, rough edges, or dark burn marks. And honestly, this is one of the most frustrating problems in CNC woodworking. Because even when the design is perfect and the machine is expensive, poor cutting quality can completely ruin the final result. But here's the good news. Most tear out and burn marks are completely preventable. In fact, professional CNC operators spend a huge amount of time optimizing their tools, speeds, materials, and cutting strategies specifically to avoid these problems. So today, we're going to explore what causes tear out, why wood burns during CNC cutting, and how professionals achieve those incredibly clean, sharp CNC edges. What is tear out in CNC woodworking? Tear out happens when the CNC bit pulls and breaks wood fibers instead of cutting them cleanly. This usually appears as chipped plywood edges, rough fibers, splintering, or uneven cuts. And some materials are much more sensitive than others. Plywood, veneered panels, oak, and softwoods often show tear out more easily because of their grain structure. The problem becomes even more noticeable in furniture production where visible edges need to look perfectly clean. One small chipped edge can ruin the entire appearance of a cabinet or decorative panel. That's why controlling tear out is such an important skill in CNC woodworking. What causes burn marks? Burn marks happen when too much heat builds up during cutting. Instead of slicing cleanly through the material, the router bit starts generating friction and heat, and that heat burns the wood surface. This is especially common in dense hardwoods like oak, walnut, maple, and cherry. Burn marks usually happen because of dull bits, slow feed rates, excessive spindle speed, or poor chip evacuation. When wood chips remain trapped around the bit, temperatures rise extremely fast, and within seconds, the wood begins to scorch. The wrong router bit can ruin everything. One of the biggest mistakes beginners make is using the wrong router bit. Different bits are designed for different materials and cutting styles. For example, an upcut bit pulls fibers upward. That improves chip evacuation, but it may splinter the top surface. A downcut bit pushes fibers downward. That creates cleaner top edges. And compression bits combine both cutting directions to produce clean cuts on both sides of the material. That's why compression bits are extremely popular in cabinet manufacturing and furniture production. Choosing the correct bit can dramatically improve cut quality immediately. Even the best router bit becomes useless when it gets dull. A sharp bit slices through fibers cleanly. A dull bit rubs against the wood instead of cutting efficiently. That creates heat, vibration, burning, rough edges, and torn fibers. And honestly, many CNC operators continue using worn-out bits far too long. Professional workshops constantly monitor tool wear because sharp tooling is critical for maintaining quality. Sometimes simply replacing an old bit can completely transform the cutting results. Feed rate and spindle speed matter more than you think. This is where CNC woodworking becomes both technical and artistic. Feed rate controls how fast the material moves through the cut. Spindle speed controls how fast the router bit spins. If the feed rate is too slow, the bit stays in contact with the wood too long and creates excessive heat. That leads to burn marks. But if the feed rate is too aggressive, the bit may tear fibers instead of cutting smoothly. Finding the perfect balance is one of the biggest skills in CNC machining. And honestly, experienced CNC operators spend years refining these settings. Material quality changes everything. Not all plywood or wood panels are created equally. Cheap plywood often contains weak glue layers, internal voids, inconsistent veneers, and unstable fibers. And all of these problems increase tear out dramatically. High-quality Baltic birch plywood, on the other hand, machines much more cleanly. The same applies to hardwoods. Stable, properly dried wood almost always produces better CNC results. Professional furniture manufacturers know that good material quality saves time, reduces waste, and improves finishing quality. Dust extraction is more important than most people realize. Dust collection is not only about keeping the workshop clean. It directly affects cut quality. When chips and dust remain trapped around the bit, heat increases, cuts become rougher, and burn marks appear faster. A strong dust extraction system improves cooling, visibility, tool life, and surface quality. This is especially important when machining MDF because MDF produces enormous amounts of fine dust. Professional strategies for perfect CNC edges. Professional CNC shops rarely rely on a single cutting pass. Instead, they use optimized cutting strategies. For example, roughing passes remove most material quickly, while finishing passes clean the edges afterward. Many professionals also use shallow passes to reduce stress on the bit. And in high-end furniture production, even tiny adjustments in toolpaths can dramatically improve edge quality. The difference between amateur and professional CNC results often comes down to these small details. Final thoughts: tear out and burn marks are some of the biggest challenges in CNC woodworking, but they're also some of the easiest problems to improve once you understand what causes them. The right router bit, sharp tooling, correct feed rates, good materials, and proper dust extraction all work together to create cleaner cuts and better finishes. And honestly, mastering these details is what separates average CNC work from truly professional woodworking. Because at the end of the day, great CNC woodworking isn't only about powerful machines. It's about precision, optimization, and understanding how every small detail affects the final result.